In this video, we're gonna talk about the Aldol condensation reaction. So what is Aldol condensation reaction? Well, this is a reaction between two carbonyl compounds to form a alpha beta unsaturated ketone as a main product. Let's take a look at an example where we have a reaction between benzaldehyde with acetophenol. Alright, so we're gonna form a alpha beta unsaturated ketone as a main product. Okay, and this reaction can be catalyzed by an acid or a base, and usually we use a base such as sodium hydroxide to catalyze the reaction, and we eliminate one water molecule as a byproduct. And this is alpha beta unsaturated ketone, the main product of our reaction. So this is the reaction between two carbonyl compounds. So we could have the reaction between two aldehydes, or between two ketones, or it could be between one aldehyde and one ketone. Another important feature of this reaction is we need at least one inological carbonyl compound. Right? So we need at least one inological carbonyl compound. So what is inological carbonyl compound? So let's take acetophenol as an example. Alright, so we have an alpha hydrogen here. In the presence of a base such as sodium hydroxide, the hydroxide will attack this hydrogen. So we have a deprotonation process here. And we're gonna form a new product. And in this product, we have a negative charge on oxygen. Again, with acetophenol in the acidic condition. So we have two lone pairs on oxygen, and this oxygen of the carbonyl functional group will be protonated by this process. We form a new intermediate with a positive charge on oxygen, and again we have a alpha hydrogen here, and the water will attack this hydrogen. Again, we have another deprotonation process, and we end up with an enol compound. So with the compound on the left, we call it enolate, and the one on the right, we call it enol. So the inological carbonyl compound is the one that can form enolate under basic condition, or enol under acidic condition. Or we can say that the carbonyl compound has a hydrogen alpha, the hydrogen at alpha position, that carbonyl compound can be enolized. Let's talk about the reaction mechanism. And I'm gonna go over the mechanism for the reaction in the previous slide. Alright, so we have acetophenol and we have a alpha hydrogen here. In the presence of a base, here we have a hydroxide. The base will deprotonate that alpha hydrogen and we form an intermediate, which is a carbon ion with the negative charge on alpha carbon. The carbon ion can undergo resonance because this is the resonance structure, and it's gonna form a enolate with a negative charge on oxygen. Since the enolate is nucleophilic, so it can undergo nucleophilic attack. All right, so we have the nucleophilic attack from the enolate to benzaldehyde. So now we have the benzaldehyde, the carbonyl of the benzaldehyde is electrophilic. We form this intermediate. Alright, so we have a negative charge on the oxygen. So we need to protonate this oxygen so that we can have a neutral molecule. So we're gonna use water to protonate this oxygen. We end up with a new intermediate, which is a neutral molecule. Alright, so we have another hydrogen at the alpha position, and this alpha hydrogen is acidic. It can undergo deprotonation by a base. So we have the deprotonation here. We use a hydroxide base to deprotonate the hydrogen, and we end up with this intermediate. Alright, so we have a negative charge on the alpha carbon, the carbon at alpha position, and we have the elimination of the OH group, and finally we end up with the alpha beta unsaturated ketone, the main product of the Aldol condensation reaction. Alright, so that's the whole reaction mechanism. So as you can see that we know the OH is a poor leaving group in the substitution reaction. So why can we eliminate the OH, a poor leaving group in this situation? Well, we know OH is a poor leaving group because it's a strong base. So the good leaving group should be a weak base, but the OH group is a strong base. So it's a poor leaving group, right? But the formation of the conjugated system will enable eliminate will enable eliminating the OS group, because the conjugated system is a stable structure, so it will favor the formation of the conjugated system. So that's why we can eliminate the OS group, a poor leaving group, in the Aldol condensation reaction.